Learn it fast, learn it smart, learn with us at SOFO. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to Concept Videos from SOFO Learning. Our topic today is linear equations with two variables. So let's start our discussions with what is the standard form of a single linear equation. Let's imagine that we have two variables, x and y. Now, how do we represent the standard form? So we have x, we have y. Now we would attach a constant term as the coefficient of these two variables. So let's imagine a to be the coefficient of x and b to be the coefficient of y. And now let's include a constant coefficient c, and if we equate all of this to 0, we will get the standard linear equation form. Again, this is a variable x, this is the variable y. These a, b are coefficients of the variables, and this is a constant term. All of it equals to 0. Now I would like you to notice that the power or exponent of these two variables is equal to 1. So this is x to the power of 1 and y to the power of 1. Why is this very important? Because if we were to plot an example equation, linear equation with these variables having exponent 1, you're going to get a straight line. Now let's look at this through an example. I have here an example equation, linear equation with two variables x and y. Let's compare this equation 2x minus y plus 3 equal to 0 to standard form. You can see here a is this value 2, b is this value right here which is negative 1, and c is this value 3. Now it's easy to rearrange this equation to have y on one side and the rest of it on the other side. Let me show you. If y moves to the other side of the equal to, then its sign will change. So it would look like y is equal to 2x plus 3, this portion. You see, now you can derive the values of x and corresponding y. These two equations are the same, and now you can attach value 1, 2, 3, 4 and all of that to this x, and you can calculate the value of y. Let's try that example, x and y. So let's just say x value is 1, 2, 3 and 4. We can calculate in our head. We are going to get 5, then 2 would be 7, 3 would be 9, and 4 would be 4 times 2 is 8 plus 3, 11. Here is the graph of the equation y equal to 2x plus 3, or this is the same graph, the same equation as 2x minus y plus 3 equal to 0. Both are same equations, and here is the graph, which, as I explained to you at the beginning of this video, is a perfect straight line right here. One of the most important things that we need to understand here is that this line has infinite points. Infinite points in the line. Now every point is actually a solution to this equation, because every single point satisfies this equation of 2x minus y plus 3 equal to 0. So every single point is a solution of the equation. Our scope actually has two linear equations in there, so let's just create one more equation and work with it alongside the earlier one that we just looked at. So here is example number 2, 3x minus y minus 1 equal to 0. Now, in the same way that we looked at it before, here is the standard form, and here is the, let's do a comparison. A is 3. The x and y are the two variables. B is minus 1 right here, and C is also negative 1. Now, we can move this y to the other side of the equal to sign, so we get the form y is equal to 3x minus 1. So now we can plot a graph using the x values and the y values. So x is 1, 2, 3, 4 in the same way, and let's find out what the values of y are. So y would be 2, then 5, then 8, and for x value of 4, the y value should be 11. Now, here is the chart or a plot of both those equations together in the same graph. The blue line corresponds to the first equation, and this orange line corresponds to the second equation. So this line corresponds to this equation, and this blue line would correspond to this equation. Now, what is interesting is this particular point. Why is this interesting? Because this line, this blue line, every point satisfies this equation, y equal to 2x plus 3, and this orange line, on the orange line, every single point satisfies this equation, y equal to 3x minus 1. So when those two lines meet, there is one single point right here that point essentially satisfies both these equations. So this one point that solves both the equations. Now we can see that this point belongs to the value 4 right here, and let's try that 4 in both those equations. All right, so let's say x is equal to 4. Then in the first equation we get y is equal to 2 times 4 plus 3, which is 8 plus 3 equal to 11. And in the second equation we get y is equal to 3 times 4 minus 1. So this is 12 minus 1 equal to 11. So y and the x value, so if x equal to 4, you get the same y value, and therefore this x equal to 4 satisfies both equations as a common solution. Thank you for watching.